In this part of the course, we move into designing and implementing embedded system on a chip. But before I get started, I want to identify what an embedded is and what system on a chip is. So an embedded system, as opposed to a general computing system like your general PC or desktop PC, is a system that has a very specific and narrow task. Maybe a few of them, but generally speaking, they're extremely narrow and it can only do certain things. An example of which is the system that you see in a microwave oven or a dishwasher. It's very specific. It can only do certain things. It's not very general as your computer. So these systems, generally speaking, have processors and peripherals. You have seen an example on an embedded system as a microcontroller before. All of you have probably seen a microcontroller and actually worked with it. And microcontroller is a type of embedded system. However, what we want to do in this course is we want to expand on it. So we're going to deal with system on a chip that are a little bit more complicated than microcontrollers. So the type of system on a chip that we were going to have processors, IOs, and maybe hardware accelerators and others as well. And because all of these components can be integrated into a single chip or a single silicon, this is why we call it system on a chip. Okay, or generally speaking, you're going to see it referred to as SoC, system on a chip, or SoC. An SoC can be designed in an Fpga, or you can use the microcontroller or any other processor that you can buy off the shelf. The difference is drastic in that whatever you buy, a microcontroller or any SoCs off the shelf, you're restricted by whatever the manufacturer of that particular SoC decided to put. So when you picked up a microcontroller, the manufacturer decided what type of peripherals, what's the capacity of these peripherals, what's the number of these peripherals. On the FPGA side that we're dealing with in this course, it actually makes it a lot more flexible because you can actually select what type of peripherals. And not only this, you can actually select the processor you want to put, the capacity of that processor, the amount of memory you put on that processor. It's very configurable on the same exact chip. And you can wipe it all out and you can reprogram in different SoCs within minutes. So an FPGA allows us to exploit this trade-offs between hardware and software. So you're not only going to be writing software, you're also going to be controlling the hardware itself. So you're not only writing assembly in C, you're also controlling the hardware. And this capacity is what we call a hardware-software co-design.